The home instruction gives you a convenient way to locate and set your home position. We'll use the same linear slide configuration that we used in the simple move video, so check that out to see how we set all this up. The only difference is I added a third limit switch to one end so we can test all of the homing modes. Let's bring up the home instruction, select the channel we want to use, and create a structure for the tags. We'll modify those tags later during runtime in the data view. Could we just put numbers in here if we wanted to? Sure, but then we couldn't control them programmatically. Let's do mode 1 first, which says move to sensor 1, and slow down, move to sensor 2, and stop. The carriage will be operating out in the middle of the slide, so we'll always want to go in the reverse direction to get back to our home position. You can use any of the 6 inputs on the HSO module as sensor inputs. We wired input 4 to be the first sensor and 6 to be the second sensor, which we're also using as a limit sensor on this slide. We want to know when the sensors go active, which is the rising edge. We do want to reset the position counter when this is done, so we enable that here. And again, we'll set all these values later in the data view. Well, that's it. Hit OK to define the tags, change any tags from integer to float that you want to use fractional amounts with, and hit OK. Now that the tags are defined, go back into the instruction and click on this button to automatically create a data view. We have a momentary push button connected to input 1 on the HSO that we're going to use as our homing button. And let's use the in progress bit to seal the contact and keep the instruction running even if we let go of that momentary switch. And transfer it to the processor. Let's bring up the data view and set up our homing. We want a fast speed to sensor 1, a slow speed to sensor 2, and some modest acceleration and deceleration speeds. When we get there, we want to set the position to 0. Let's add the channel 1 position and velocity to the data view and plot the velocity so we can see what happens. Well, let's try it. Put the processor in run mode, and don't forget to rewrite all of your edits to memory. They get cleared when you go into run mode. I'll hit the home button, and sure enough, you can see on the graph that the slide moved quickly to sensor 1, decelerated, then crept to sensor 2, where it stopped and set the current channel position to 0. Perfect. Now, could we have used the same sensor for both positions? Sure. We could have looked for a rising edge as the first sensor and the falling edge as the second. That works really well if you have a wide sensor detection range. Modes 2 and 3 are simple. Move to the first sensor and stop immediately, or move to the first sensor and decelerate to a stop. I don't think we need to demo those. But let's take a look at mode 4. That one's more interesting. This one detects a sensor, decelerates past it, then reverses direction and creeps back to the original sensor. Note that it looks for the rising edge on the first hit, and then it looks for the falling edge on the second pass, so you end up right at that first edge. This mode is a great way to get rid of backlash when you're homing your system. Let's try that. I'm going to bring up the high-speed test tool and put the processor in stop mode so I can use the tool to manually move the carriage back out to the center of the slide. Okay, shut that down, move it out of the way. So we want to go fast to the first edge and slowly creep back, and I'm going to slow down the deceleration to make sure that we go past the sensor. Let's get back in run mode and rewrite those edits that run mode just cleared. Hit the home button, and sure enough, we see on the graph that the carriage ramped up to a fast speed, found the leading edge of the sensor, decelerated, and then moved backwards to find the trailing edge of the sensor, and then set the current channel position to 0, just like we asked for. Notice that when using the home instruction, you never use negative values for speed. You specify the initial direction here, and then everything else is relative to that. For example, the instruction knows that when using mode 4, the second velocity moves in the opposite direction. You don't put a negative value here. And as always, if things don't work as expected, take a look at the status word bits. If you see one bit set, just look it up in the help file, and it'll usually tell you exactly what the problem is. And one of my favorite features of the Productivity Suite software is you can test bits in a word directly. Just bring up the status word, tell it which bit to test, and you're done. You don't have to do a bunch of math or masking or shifting or testing of bits. This built-in bit of word feature does it for you. The beauty of all this is the Productivity Suite software makes all of this so easy to set up and test independent of your actual application. So when you do go to write your ladder code, you already know the system works and have narrowed down the settings that you'll need, which makes your programming life go so much smoother. If you need any help with the productivity series of controllers, contact Automation Direct's free, award-winning support team during regular business hours. They'll be happy to help. And don't forget the forums. There are lots of folks there that love to share their years of experience. Just don't post any questions directed at Automation Direct support team there. They don't monitor the forums on a regular basis.